In this video, I'll show you how to solve this rational applications problem. Bob can paint the fence in 6 hours and Sam can paint the fence in 10 hours. How long would it take both men working together? So our first step would be to underline important information. Bob can paint the fence in 6 hours. So Bob can paint the fence in 6 hours and Sam can paint the fence in 10 hours. And then our question, how long would it take both men working together? Now, one method that I use to approach this problem is I call it the fraction method. Basically, what you do is, I'll write a formula here. So basically what you would do is 1 over number of hours for first person. Then I would have this plus 1 over number of hours for second person is equal to 1 over number of hours working together. So you would have 1 over number of hours for first person plus the number of hours 1 over the number of hours for the second person is equal to 1 over the number of hours working together. Now, let's go ahead and just substitute our information into the given formula. So Bob can paint the fence in 6 hours. So we'll just have Bob equals first person. And then we can have Sam equals second person. Now let's just sub them in. So now we have 1 over Bob can paint the fence in 6 hours plus 1 over number of hours for Sam, so 10 hours, is equal to number of hours of them working together. Now, the question is asking us to find how long it would take them working together, so we don't have that. So what we can do is we can just replace it with an x. So 1 over 6 plus 1 over 10 equals 1 over x. Now, our next step, once you've gotten to this point, what you want to do next is you want to take your two given numbers. So in this case, our two given numbers are 6 and 10. And what you want to do is you want to find the LCM between those two numbers, so the least common multiple. So here we have LCM of 6 and 10. What would that be? So we would have 6 times 1, 6. That doesn't work. 6 times 2, 12. That doesn't work. 6 times 3, 18. That doesn't work. 6 times 4, 24. That doesn't work. 6 times 5 is 30, and that does work. And 30 would be our lowest. So that means LCM would be 30. Now that we know our LCM, what we can do is we can take that 30 and then we can go ahead and just add just a little 30 on top of each of these fractions. And what this does is that it makes it easier to cancel off. So basically what we're doing is we're taking that LCM and then we're multiplying it we're multiplying the entire equation that we originally had by 30, by our LCM. And this allows for easy cancellation. So this can be canceled, and the denominator will be canceled. This will become multiplied by 5, because 30 divided by 6 equals 5. Next, we have 30 and 10. 30 divided by 10 equals 3. So we can cancel 30 and cancel 10. And then we multiply what these two are equivalent to. Well, like what the product of what they're divided by. And we just multiply it into the numerator. And then finally we have 30 and x. We can go ahead and just cancel them out and then multiply by 30 because x can't actually be divided by. So we have 1 times 5 plus 1 times 3 equals 1 times 30. But what happens to that x? We can't just get rid of it. What we have to do to that x is, when we rewrite this, we basically have to bring this x that we originally had as our number of hours working together. We have to bring it, and then we add this x on here, and then we remove the x from the number of hours working together. So I'll just show you. Our new equation will look like this. Our new equation will be 1 times 5 is 5. And remember, we have to distribute that x. So 5x plus 1 times 3 is 3. And we distribute that x equal to, and we should have 1 times 30, but we just don't add the x on the end. So basically, you're just flipping it. So instead of having the x over here, you're just moving it over to these two. So you're just taking it, distributing it to the others, and then you're getting rid of the x on this side, where it originally was. So say hypothetically, we're trying to find this number. Say it was 1 over x here. We would put the x onto these two, but we would have no x on this one. So basically, the two proper fractions will have an x at the end of it on our final equation. Now we can go ahead and just solve this. We can have 8x equals 30. Then what we have with this is isolate the variable, divide by 8. X equals 30 by 8. And that means x is equal to 3.75. And that would be our final answer. So the answer to how long it would take both men to work together, it would be 3.75 hours. So this is how you solve it. Just to recap, so first you're going to want to plug into this equation, we have. So 1 over number of hours for first person plus 1 over number of hours for the second person equals 1 over the number of hours working together. And then you're going to go ahead and plug it in. And then you're going to find the LCM, and in this case it was 30. Then you put that little 30 up top, and then you can go ahead and cancel. And then whatever is your remainder, you're going to put it into the numerator, such as like 30 divided by 6 equals 5. So we put 5 in the numerator. You did so here. And then this is the part that you have to remember. When you have 30, say 1 over x, that means you're just going to take this LCM, you're going to multiply it to our 1, and then when we bring it over here, we're going to distribute that x onto these two, but with the original equation, with the x, so 1 over x, we're not going to have an x on that in the final solution. So, the final equation. So then we have distribute the x, 5x plus 3x equals 30, and then we simplify from here, and x equals 3.75 hours. Thank you for watching this video. Be sure to like, subscribe, and watch out for future videos. Thank you.